This is a walkthrough of our final project for ECE 314. We chose the Gaussian filter project in MATLAB. The students involved were Madeline Wong and Grace Dean. Our Gaussian filter design was based on the convolution function in MATLAB. We started with a Gaussian kernel. The kernel could be any size. We chose a size of 9. And we started with a sigma standard deviation of 1, which is quite small. A Gaussian filter will smooth a two-dimensional image. It will also remove Gaussian distributed noise. When it blurs the image, it acts as a low-pass filter, it removes high frequencies. The first step in creating our Gaussian kernel was to make sure that we had a kernel of size 9 that was centered on the origin. This line here. We created a mesh grid, which is a 2D grid for the Gaussian function to be applied to. This is our Gaussian function. The only part of it that's missing is the scaling factor so that we can normalize our function. We do that at a later step. I'm going to go ahead and run the code so that you can see a three-dimensional surface plot of our non-normalized Gaussian kernel. You can see in this three-dimensional surface plot that we have quite a sharp incline, and most of the weight of the Gaussian filter or the Gaussian kernel is in the center at the origin. That will change as we have larger and larger sigmas. At this point, this is the step where we are going to normalize our Gaussian kernel. The way this is accomplished is by taking the Gaussian kernel and dividing it by the sum of all the values in the Gaussian kernel matrix. And when we do that, we end up with a normalized Gaussian kernel function. I'm going to take us to the command window so that you can see this is our Gaussian kernel before normalization. The central value is 1, that's where the greatest weight is. The normalized kernel here, the central value is still the largest, but all these values together sum to 1. The next step in our script is to read an image into MATLAB and prepare that 2D image for convolution. The image that we're going to start with is Cameraman Tiff. That's a grayscale image. This next step would be to take that image that is currently in an 8-bit unsigned integer value form and convert it to a double precision floating point value form, which is accomplished here. The next step is to go ahead and do the convolution of that image with the Gaussian kernel that we made earlier. That's accomplished here. This function, convolution, but with n, allows us to do a convolution with something that's not just a matrix. We can do an array with more than one dimension, or multiple dimensions, more than 2 dimensions. And for a color image, there are 3 dimensions in that array, so that is crucial. The same here, make sure that after the convolution, that the returned image is the same size as the input image. And then also convolution, the convolution function in MATLAB automatically does zero padding at the edges so that we don't get strange values at the edges. The last step is for us to convert that double precision image back to our 8-bit unsigned integer value. And I'm going to go ahead and run this script so that you can see our original and our filtered image. All right, so here's our original image. Our filtered image is only slightly blurred. So I'm going to take us back to the top and let's change our sigma value to 3 and run it again. You can see this is significantly more blurred. Okay. Let's change out our image here for this one, Pepper's PNG. That is going to be our color image. And you can see that we have the original image in color, and then we have our blurred image in color as well. The last image I'm going to show you is called PoutTIFF. This is another grayscale image, but I want to show you that, first of all, I'd like to show you that we can make the sigma even larger. Like, let's do something a little bit absurd. 10, we'll change our Gaussian kernel to 30, size of 30. I'm going to run it, and yeah, you can see that we've almost lost the image through the blur altogether. Okay, let me change that back to something reasonable again. Okay, there's two things that I would still like to show you. The first is a three-dimensional surface plot of our normalized Gaussian kernel, but with 3 sigma. The last thing that I want to show you is how our blurred PoutTIFF image compares to the MATLAB function, which is the pinnacle of blurring performance in MATLAB. So I'm going to run our script. Okay, I'll stick these to the side for a second. So you can see this is our normalized Gaussian kernel, but this is with sigma 3. And you'll recall that with sigma 1, we had a very, very steep incline, and all of the weight was centered around the origin. Our weight has been more evenly distributed now, and that is reflected in the blurring of our images. Comparing the two images, this is the image from the filtered image from our filter, and this is the MATLAB filtered image. You can see that they are pretty close. I would guess there is some variation in the size of the mask. I'm unable to see what they chose for that. I can show you, though, that we have a sigma of 3, and in the MATLAB function down here, they also, we have an inputted sigma of 3. And the function that you would use for that, if you want to use the best filter, Gaussian filter there is ImGaussFilt. Thank you so much for your attention.